Hey, welcome. This is your LI AI. Today we are designing an online chess platform, the kind of real-time system design that shows up at OpenAI, Meta, Google, Anthropic, Stripe, Upstart, and a lot of other places that care about sticky sessions and fair clocks. Picture a 3-minute blitz game. You're on mobile in Singapore. Your opponent is on fiber next to the data center. You both play fine chess. You still flag first. Why? Because every move you send spends more time in transit, and a naive server charges that transit against your clock. Over 40 moves, 170 milliseconds of extra one-way delay is nearly 7 seconds of your life gone to the network, not the board. The naive design sounds tidy. Poll for the opponent's move over rest. Let the client own a countdown timer and report remaining time. Stick each WebSocket wherever the load balancer feels like. Isolation for free. Then the interview falls apart. Polling misses a 200 millisecond move budget. A client clock is a cheat vector. Random load balancing puts the two players on different game hosts, and now validation races and clocks disagree. So today's real problem is not raw QPS. It's holding hundreds of thousands of stateful, ordered two-party games, about 500,000 concurrent games, a million connections with server-validated moves, honest clocks, and skill-based matchmaking that doesn't double book anyone. By the end of this walkthrough, you should be able to lock requirements, draw the end-to-end path, and defend three deep dives: matchmaking without zombie claims, sticky game hosts with clock bleed refunds on failover, and latency aware server clocks, plus a staff note on desync hashes and zero time pre-moves. If you've practiced chat or ride hailing designs, same muscles: clarify, interface, bottleneck, trade offs. The bottleneck here wears a chess clock. Let's lock requirements. One more beat on why this interview is deceptive. Candidates hear chess and start drawing a CRUD app with a leaderboard table. Interviewers hear chess and want to know whether you understand sticky real time state. Can both players find the same memory? Can the clock stay fair when networks are not? Can matchmaking survive contention without double booking a human? Those are the questions that separate a mid answer from a staff answer. On screen, we'll rotate through four hook visuals while I talk: lag scene, naive failures, architecture sketch with company marks, then the roadmap. Same pattern we use on other your LI AI long forms. The hook is a storyboard, not a bullet list you stare at for 4 minutes. Today's promise is practical. You leave able to redraw the boards cold and defend the deep dives without sounding like you memorized a blog. Let's lock requirements. Next section: requirements. We lock functional requirements, non-functionals, and what stays below the line before any boxes appear on the board. That discipline prevents scope creep and shows product sense. Alright, requirements. Keep the core list tight, then check with the interviewer before you invent a social network. Functional requirement 1: players find an opponent through skill based matchmaking and start a game. Same time control, similar rating, not a random stranger who happens to click play. Time control matters. 3 plus 2 is a different product from bullet 10, and players only want peers who picked the same clock. Functional requirement 2: they play in real time. The server validates every move and owns both clocks. Clients render pieces and paint a countdown. They do not invent legality or remaining time. If you let the client own either, you have already lost the interview. Functional requirement 3: a global leaderboard and your own rank, updating shortly after game's end. Ratings change when games finish, not continuously mid-move, which makes caching honest. Below the line for this interview, spectating popular boards, chat and friends, puzzles and analysis, tournaments and full anti-cheat. Say anti-cheat out loud. Engine assistance is an existential product risk. Then park it as offline behavioral ML, not today's hot path. Spectating is a read fan out problem. Do not hang watchers off the authoritative game host. Non-functionals, pin scale first, 500,000 concurrent games at peak. Two players each means about a million WebSocket connections, plus validation and two clocks per game. Those numbers carry through every deep dive. Latency, move propagation under 200 milliseconds end to end. In bullet and blitz, seconds per move means delay feels broken. Consistency over availability for live game state. If a host cannot be reached, pause rather than let boards diverge. A paused game recovers, a corrupted one does not. Interviewer constraints that force later boxes, one authoritative host per gameid, clocks advance only on server events, the move log is recovery, clients never supply rating, and disconnects may use an abandoned timer instead of instant forfeit. What you'd say, assuming skill matchmaking, server validated real time play, leaderboard with own rank, P95 moves under 200 milliseconds, 500k games, and pause on failure. Next, APIs and entities. Hold the line on below the scope items when the interviewer pokes, acknowledge spectating and anti-cheat, then return to the three FRs. Let me slow down on consistency versus availability because candidates recite CARP and then design for both. Here the product tells you the answer. Two clients with different boards is not an outage. It is a corrupted competition. Pausing for a few seconds during host failover is recoverable if you refund the clock. Divergent finish strings are not. So when a game server becomes unreachable, we stop the clocks, so paused and recover. We do not let either client keep inventing moves against a ghost. Same honesty on scope. If the interviewer loves spectating, say yes. Popular boards are a pub sub fan out with hundreds of milliseconds of lag acceptable. Then put it below the line. Authoritative gameplay, stage a two-party sticky session. Mixing those paths is how designs get messy. Next section, APIs and entities. We name player, match request, game and move. Then split REST matchmaking from the WebSocket play protocol, including the traps interviewers listen for. Entities first, vocabulary before endpoints. Player holds identity and elo. That number drives who you meet and where you sit on the board. Match request is the desire to play. Player id, server copied rating, time control, status pending or matched, created at, and the widen window as weight grows. Keeping match requests separate from game gives matchmaking a noun to own. Game is the match itself. Seeds, colors, status, clock seeds, start rating snapshot for elo math, result, and last move timestamp. That timestamp is how we refund clock bleed after failover. Do not skip it on the entity board. Move is append only history. Move number from to server timestamp. Zobrist has after apply. Optional is pre-move. The log rebuilds boards when hosts die. Disconnection state is operational per seat. Disconnected at abandoned deadline, say 45 seconds, and whether we are in normal ticking or abandoned mode. A 3-second mobile blip should not forfeit. An endless stall should not freeze the opponent forever. APIs split, matchmaking and leaderboard are REST. Gameplay is WebSocket. Post matchmaking with time control only. Long poll until matched or widen and expire. Identity from JWT. trap: never accept player ID or rating from the body. Candidates do this constantly. Anything you could lie about to get an easier opponent must be server read. WS Games slash gameId. Client send move carries from to move number is pre-move. Client timestamp. Move number makes retries idempotent. Is pre-move marks 0 time staging. Client timestamp is a lag hint, not authority. Server pushes MoveAC and opponent move with white timems, black timems, Zobrist has or fan and leg ready times. Hash mismatch means resync the board without tearing the socket. On failover, game paused, then game resumed with refunded Ms after clock correction. Game end covers mate, draw, flag, resign, abandon. Get leaderboard with cursor. Get rank for yourself. Top N is easy. Exact rank at 10 million players wants a sorted set later. Name that without overbuilding the API board. Product beat next, then math. One more pass on the trap. If the interviewer asks why rating is not in the body, say cheat surface. Easier opponents on demand. Server owned rating is a fairness control, not pedantry. Think about what the client is allowed to know. The client may propose from n to squares. The client may stage a pre-move. The client may not declare how much time they have left. The client may not declare their rating for matchmaking. The client may not pick which game server they prefer beyond connecting to the URL we issued. That permission boundary is the API design. Everything else is sugar. Idempotency belongs in the contract. Move number on send move means a retried packet after a network blip does not move twice. On the server, accepting the same move number twice is a no opaque with the same clocks. Similarly, game end processing keyed by gameId means LO apply can retry safely. Interviews love hearing that you thought about retries before the deep dives. For leaderboard gets, cursor pagination beats offset pagination at scale. Say why briefly. Offsets get expensive as you walk deep pages. Cursors write the rating index. On rank can be approximate in a mid answer and exact via sorted set rank in a senior answer. No both. If you want to practice this live, mocks, system design loops, FR probes under a clock, sign up on your LI AI at your li.live. I'm going to click through the product briefly so you can see what that looks like. Alright, back to the design. Envelope math next. No pressure. If you're here to learn, stay with the boards. If you want reps under a timer, your LI AI is built for that. Sign up at your li.live when you're ready. Envelope math next. Numbers before boxes. Take 30 seconds, open your li.live if you want, and imagine running this exact FR list in a timed mock. I'll click the product so you can see the flow. Back to math. Back of envelope, chess units on the whiteboard. Connections. 500,000 games times 2 is a million WebSockets. That alone means a fleet, not a hero box. Match RPS, fast controls requeue about every 2 minutes. A million active players over 120 seconds is roughly 8,000 match requests per second, and peaks climb into the tens of thousands. A match is not a point lookup. It is a range search plus a claim. Redis, about 4 ops per match times 30,000 is 120,000 ops per second. Hottest time control key may be 50,000. Single threaded Redis sorted set throughput sits in the low hundreds of thousands per second, so one node still has headroom. Say the textbook sharded banned answer, then prove you do not need it yet. Sharding adds bandage bugs. Host's idle connection capacity is not live validation capacity. Expect dozens to low hundreds of game servers. Memory, A position is hundreds of bytes. RAM is cheap at 500K games. We still prefer in-memory ownership for latency, not because Redis could not hold the bytes. Persistier classical can sync append inside 200 milliseconds. Bullet cannot donate jitter to the clock except under a millisecond, broadcast, async WL, or stream to Postgres. Those numbers justify the diagram next. Write the 5 numbers on the board as you speak. 1 million connections, 8 to 30,000 match RPS, about 120,000 Redis ops, dozens to hundreds of game hosts, and the persistier is split by time control. Interviewers remember the board. A worked example helps the room. Suppose we run 100 game hosts, that is 5,000 concurrent games per host at peak if perfectly balanced. Aggressive but illustrative. Each game has 2 sockets and a small hot state machine validating moves. The bottleneck is more often CPU and fair scheduling of many games than raw RAM. That intuition stops people from proposing one giant Redis house of all boards as the life path. On matchmaking cost, even if Redis is fine, the product cost of bad matches is player churn. Envelope math is not only machines, it is wait time at the extremes. When you quote 8,000 match requests per second, also say you will measure P95 time to match by rating bucket and widen based on that curve. Next section, high level design. One end-to-end board, matchmaking into Redis, sticky game hosts, tiered move persistence, and idempotent rating updates when games end. High level design. Draw this as a player journey and narrate failures while you point at boxes. Start left. The client posts matchmaking through an API gateway with a time control like Blitz 3 plus 2. The matchmaking service ignores any client supplied rating fantasy, loads ELO from the player record, writes a match request and ZADs into a ready sorted set keyed by that time control with score equal to rating. Pairing is not a casual read. Two workers can see the same waiting human. So we claim with Lua and we claim in 2 phases. Move the pair into a pending game lease with about a 5-second TTL. Insert the game row in Postgres with start rating snapshotted, then finalize the lease. If the worker dies between claim and insert, the TTL expires and both players auto requeue. That zombie claim fix belongs on the HLD, not as a footnote. When matching succeeds, both long polls complete with gameId, color, and a WebSocket URL. Now the play path. Both clients connect through a session router that consistent hashes on gameId into a membership registry, Zookeeper, etcd, or console in interview speak. The unstated requirement is affinity. Both seats must share one game service process holding the board and both clocks in memory. Chess state is a few hundred bytes and lasts minutes. That is why stateful memory beats shared store per move on the hot path. Shared store would spend your latency budget to solve a memory problem you do not have. On each move, the service validates legality and turn, updates a Zobrist hash, flips clocks, and stamps last move timestamp. Then tiered persistence for rapid and classical, append the move to Postgres before you broadcast. If you act first and crash, recovery returns a board missing a move both players already saw. Exactly the corruption we refuse. For bullet and blitz under 3 minutes, except in memory under a millisecond. Broadcast immediately and flush asynchronously through an in-memory WL or Redis stream into Postgres. Say the trade-off out loud. Bullet intentionally accepts a tiny durability window so database jitter cannot eat the clock. Consistency still wins on conflict. pause rather than diverge. Outbound frames are move-ek and opponent move with authoritative times, has or fen, and leg credit times. On terminal results, mate, draw, flag, resign, abandon, write game.result, then apply ELO idempotently keyed by gameId into players and a leaderboard sorted set. The result row is source of truth. The leaderboard is a derived view you can rebuild. Failure tour. Redis matchmaking primary dies. Pending pool is ephemeral. Clients resubmit. Pool refills in seconds. That bar is lower than game host. Game host dies. Pause. Reassign via the registry. Replay the move log. Refund clock bleed using last move timestamp. Emit game resumed. Generation fence so the dead process cannot write. Postgres slow on bullet. Async path already protected the felt latency. Deploy prefer draining so healthy games do not reshuffle on membership change. Name Aka or Orleans style systems as production cousins without requiring you implement them today. Every box maps to an FR or an FRV locked. If you can rename this diagram into generic chat, you failed the rename test. Rewrite until chess constraints are load bearing. Next, sequences up close. While the diagram sits on screen, plan the deep dive hooks without solving them yet. Point at Redis and say claim races and zombie leases live here. Point at the router and say both players must hash together and failover must refund clocks. Point at the game service and say bullet persistence is intentionally async. Point at leaderboard and say exact rank is a sorted set problem, not SQL count. You are teaching the interviewer where you want to spend the remaining time. Also label data ownership. Postgres owns players, games, and moves as system of record for completed facts. Redis owns ephemeral match pools and optionally rank indexes and async flush streams. Game process memory owns the live board. When someone asks where is the truth, you answer with which question? Live position versus durable history versus matchmaking pool. Two sequences on the board, match, then move. Match, post time control, service, judge the player. Lua finds a compatible rating peer and moves both into a pending a game lease with a 5-second TTL. Worker inserts game in Postgres with start ratings snapshotted, finalize lease, complete both held HTTP requests with gameId, color, opponent summary, WS URL. If the worker dies after claim and before insert, TTL expiry throws both players back into the sorted set automatically. That is the zombie claim story in motion. Move, clients connect sticky, white send move with move number is pre-move client timestamp. Server checks turn and legality in memory. On success, news obrist, stop white clock, start black, set last move timestamp. Persist per tier, push move back to white and opponent move to black with times, hash, lag credit M's. Reject illegal moves with a reason and change nothing. Pre-move path, opponent move arrives. In the same server tick, evaluate the queued pre-move. Legal means apply with zero server clock consumption. Illegal means discard, no penalty for the attempt. Stacked pre-moves apply in order until one fails. Failover, pause, reassign, replay moves, failover gap equals now minus last move timestamp, refund active seat, emit game resumed with refunded M's. Generation fence blocks the old host. Ordering rule to tattoo on your brain. Players should not observe state, the recovery path cannot rebuild, except the intentional bullet async window you called out. Idempotency fences, move number, and game educate elo apply. Deep dives next. If you forget everything else from the move path, remember persist ordering and idempotency fences, move number on send move, gameId on elo apply. Retrees become boring and boring is correct. Walk a concrete illegal move. Black is in check but tries to move an unrelated pawn. Server rejects with moveac accepted false and a reason. Clocks do not flip. Opponent receives nothing. That boring path matters. Candidates forget rejection semantics. Walk a disconnect. White socket drops mid-turn. Disconnection state starts an abandoned timer. Black sees a disconnect indicator, but the server still owns the position. If white returns before 45 seconds, resume. Clocks follow server policy you stated. If not, game end with abandon. Keep that separate from flag on time. Walk match timeout, no peer after widened schedule. Long pole returns a clear timeout. Match request expires. Player can post again. No ghost entries left in Redis because expiry and client retry are part of the protocol. One more concrete walk, draw offer is out of scope for mandatory design, but if asked, server mediates agreement. Both seats must confirm. Never trust one client saying draw accepted. Same contents and pattern as matchmaking claims, smaller blast radius. Pre-moves again in sequence language. Opponent move lands, server applies it, then immediately tries the queued pre-move before yielding to the event loop. That same tick property is what zero time means. If you apply pre-move on a later tick, you accidentally burn clock. After both sequences, tell the interviewer which deep dive you want first. Strong candidates drive, matchmaking contention, host affinity, clock fairness. We will do all three. Next section, deep dives. Wrong versus correct on matchmaking claims, sticky host failover with clock refunds, and fair clocks under uneven latency, plus desync hashes and zero time pre-moves. Deep dive 1, matchmaking without double booking. This is where contention lives. Wrong approach. Every matchmaking request scans a shared Postgres table of pending players for someone within plus or minus 200 rating points and the same time control. At quiet scale, it works. At peak, we derived tens of thousands of match requests per second. A match is a range search plus a read modify write claim. The middle of the rating bell curve is hot. Almost everyone is a compatible match for almost everyone else. So the same handful of waiting players become candidates for huge numbers of workers at once. Lock pessimistically and you serialize the platform. Go optimistic and workers race. Most lose the compare and set and you burn retrees. Either way, the table melts. Correct approach, read is sorted, set per time control, score equals rating. Incoming requests Z themselves. A worker ranges for the nearest compatible scores. Then a Lua script atomically claims exactly two members. Progressive widen, start at 200, grow to 400 and beyond as wait time grows. So rating extremes are not stranded forever. Expire around 30 seconds and tell the player to try again rather than wait infinitely. Staff edge case, the zombie claim, the Lua claim succeeds. Both players are removed from the free pool. Then the worker crashes before Postgres inserts the game. Those humans are matched in limbo with no gameId and no path back to the pool. Fix with a two-phase lease. Lua moves them into pending game with a 5-second TTL instead of a permanent matched flag. Creating the game finalizes the lease into matched. If the process dies, TTL expiry automatically requeues both members into the sorted set. No nightly cleanup job for the common crash. Should you sort pools across Redis nodes by rating band? Name the textbook yes, then usually decline with math. Hottest single time control key, around 50,000 ops per second still sits under a healthy node's sorted set capacity with headroom. The pending pool is tiny in memory. Sharding adds bandage bugs where two near equal players land in different buckets and never meet. Revisit only if one time control grows several times past today's peak. Thin pool probe, a 2800 rated player, may have almost no peers online. Narrow windows mean infinite wait. Instant wide windows mean unfair games. Progressive widen tied to wait time is the product answer. In production, you tune from wait time metrics. In the interview, you describe the policy. Redis availability, run replicas with automatic failover. Losing the pending pool is annoying. Clients requeue. Keep that failure domain separate from authoritative in progress games. Compare this to ride hailing briefly without derailing. Uber style matching also pairs two parties under contention with widening criteria. Chess widens rating. Rides widen distance or ETA. The atomic claim lesson transfers. What does not transfer is the sticky two party game that follows. After the match, chess becomes a long lived, stateful session, not a short dispatch. Separating those phases keeps your design clean. Operational metric to name, time to match histograms by rating, decile, and by time control. If bullet matches in 1 second but classical waits 30 at the extremes, your widen policy is wrong for one of them. Staff candidates mention the feedback loop from metrics to widen parameters. Deep dive 2, both players on the same host, and what happens when that host dies. Wrong. The load balancer treats each WebSocket as an independent connection. White lands on host A, black on host B. Moves bounce between machines. Validation becomes racy. Clocks desync. Sticky cookies keyed on. Connections still fail across devices and reconnects. The unstated requirement is server affinity per gameId. Weak candidates miss it. Strong ones reach for consistent hashing early. Correct hash gameId into a membership registry of game servers. Both connections route to the process that owns that game's memory. Board, turn, clocks, last move timestamp, pending pre-moves. On node death, the ephemeral membership node disappears. Affected games pause. Consistency over availability. We would rather freeze than diverge. Reassign deterministically. Rebuild by replaying the durable move log into a fresh in memory board. Then resume. Chess games are short. You rarely need heavyweight snapshots. The move log is the recovery mechanism. Add a generation or epoch fence so the old process cannot accept moves after it has been replaced. Staff edge clock bleed. Failover takes wall clock time. If the active player's clock keeps running across that gap, your incident steals their bullet seconds. That is indefensible product behavior. Persist last move timestamp whenever a move is accepted or a clock switches. On resume, compute failover gap is now minus last move timestamp and explicitly refund that duration to the seat that was on the clock. Push game resumed with white times, black times, and refundables. So both clients agree. Infrastructure recovery is on the platform, not the player. Reconnect and abandon. Mobile clients drop constantly. Reconnect to the same gameid route. Resume from move number. Trust only server clocks. Keep an abandon timer about 45 seconds separate from normal ticking so a 3-second blip is not a forfeit and a vanished opponent is not an infinite stall. Production honesty frameworks like Echo cluster sharding or Orleans virtual actors make placement a directory a coordinator owns and draining deploys avoid reshuffling healthy games. Leicester style systems live in that world. In a whiteboard interview, hashing plus registry plus log replay plus clock refund already carries staff signal. Then name the framework path as what you would ship. Probe who pays for 800 milliseconds of reassignment. Answer the platform via refund. Durability nuance with tiered persist during failover. If a bullet game was on the async path, the WAL or stream must be readable by the replacement host, or you replay only what Postgres has and accept you might be slightly behind what was briefly shown, which is why some designs still sync a compact checkpoint periodically even on bullet or block broadcast on stream Eki with millisecond timeouts. In the interview, pick a clear policy. Either async flush is guaranteed before broadcast returns to the process event loop via stream under a millisecond budget, or you accept rare rollback on crash and pause the game. Do not handwave. Multi-tab login, same player ID, two sockets. Define whether the second connection displaces the first or shares the seed. Either works, state it. Otherwise, demos look like desync bugs. Deep Dive 3, Fair clocks when networks are unequal, plus desync and pre-moves. Wrong, the client tracks a timer and reports remaining milliseconds. That is a hard fail. Cheating is trivial, and you told the interviewer you do not understand authority. Good server authoritative clock with no compensation. Better than cheating, still unfair. Player A 30 milliseconds from the server and player B 200 milliseconds away lose different amounts per move. Over 40 moves, B can donate nearly 7 seconds to transit alone. Geography becomes rating. Mobile and far regions lose through no fault of their play. Great server authoritative clock with latency compensation. Estimate one-way delay from heartbeats and observed move RTTs. On each accepted move, credit a clamped lag credit EMS. Put that credit on MoveAct and opponent move so both UIs stay honest. Use client timestamp as a measurement hint only. Never edge authority for remaining time. Bound the credit hard so a player cannot mint free clock by forging lag. State desync, networks flap, UIs race, embed Zobrist hash or FAANG on every authoritative frame. The client recomputes its local hash after applying the move. On mismatch, request authoritative state and self-correct the board without tearing down the WebSocket. Reconnect is for transport failure. Check some mismatch is a resync. That distinction keeps bullet playable on barred networks. Zero time pre-moves. Bullet players stage moves before the opponent replies. Client sends is pre-move true. When the opponent's move is accepted, the server evaluates the queued pre-move in the exact same tick. If still legal, apply immediately with 0 milliseconds of server clock consumption. If the reply made it illegal, check, capture, pin, discard cleanly with no clock penalty for the attempt. Strong players stack several pre-moves. Apply in order until one fails. This is server scheduling discipline, not a client animation trick. Pair it with async bullet durability so the pre-move tick is not blocked on Postgres. Do not double dip corrections. Failover refunds and lag credits are both bounded infrastructure adjustments. Together, they must not create infinite time. Probe Singapore mobile versus data center fiber in the same bullet game. What do you credit and what do you refuse to trust? Increment time controls 3 plus 2 interact with compensation. The plus 2 is added on move accept after lag credit policy. Be consistent. Lag credit adjust the deduction for thinking plus transit. Increment is a separate rule. Write both in the protocol so clients do not double apply. Flag detection is server side. A clock hitting 0 between moves should emit gameId without waiting for a client to confess. That means the game process schedules timer events, not only move events. Another reason state belongs in a sticky process with a clock wheel or heap of deadlines. Before recap, if you want to pressure test failover and clock probes under a live mock, your LI AI is at your li.live. Let's close with what to say in the room. Same invite as before. Your LI AI at your li.live, then we close. Last product beat before recap. If failover and clock probes are the parts you want to rehearse live, your LIAI is at your li.live. Recap next. Recap section, portable checklist, 3 probes to practice, and a clear invite to rehearse on your LIAI. Recap, what to say when the interviewer asks you to summarize. Server owns moves and clocks. Both players land on one sticky host keyed by gameId. Matchmaking uses a Redis sorted set with a two-phase lease so zombie claims cannot trap anyone. And you widen for thin pools. Persist sync before broadcast on slower controls. For bullet and blitz, except in memory, and flush asynchronously, so database jitter does not eat the clock. Failover refunds clock bleed via last move timestamp. Frames carry Zobrist hashes and lag credits so clients self-heal and UIs stay honest. 3 probes, thin, high elo pool, widen with weight. Host death, pause, replay, refund. Asymmetric RTT, compensated server clocks, never client timers. Below the line, anti-cheat and spectator fan out, name them so you sound product aware, then leave them undesigned today. Practice those probes on your LIAI at your li.live until the answers feel boring. Boring is the goal. Redraw the HLD once cold, then go defend it. Thanks for watching. Redraw once without notes tonight. If lease affinity tiered persist and clock refund still appear, you are ready for the room. Closing checklist you can screenshot mentally. Server authority on moves and clocks, sticky gameId routing, Redis match pool with two-phase lease, widen thin pools, tiered persist by time control, failover pause plus clock refund, Zobrist on frames, zero time pre-moves, leaderboard as derived view, anti-cheat named and deferred. Practice on your LI AI at your li.live. Carry the probes into a mock until they feel automatic. Thanks for watching. Go redraw it cold. If you only practice one diagram this week, practice the HLD with lease, sticky host, and tiered persist labeled. If you only practice one verbal probe, practice clock bleed refund with a number. 800 milliseconds of failover should not appear on the player's clock. Your LIAI at your li.live. Rehearse until the answers are calm. Thanks for watching.